Let's imagine that we've got a block here, and this block we will say has a mass. Whoops, hold on, I got to get a different pen here. Let's imagine that this block has a mass of 5 kilograms. Okay, and we take this 5 kilogram block and we put it on an inclined plane, which is basically a hill. And let's say that this hill has a angle of 30 degrees to the horizontal. So it's at a 30-degree angle to the horizontal. We'll say that this is the ground here, and this hill is 30 degrees above the ground, and this block is just resting there on that hill. Now, we know that the force of gravity acts on all objects, and when the force of gravity acts on an object, it pulls it towards the center of the earth. And so if I were to put a vector on here for the force of gravity that this block feels, it would be towards the center of the earth, which would be straight down, because this is the ground here, so straight towards the center of the earth. So it would be like this. Force of gravity that this block feels would be straight downwards, like that. And we'll label this the force of gravity. And remember, we learned that the force of gravity is basically the same thing as saying the weight of the object. So we can either use Fg or W. They're both saying the exact same thing, so which is equal to mass times the acceleration due to gravity. So force of gravity is equal to the weight which is equal to the mass times the acceleration due to gravity. Now, that's the force that this box feels. That's straight down. Now here's the thing, this is at an angle though, and so we could actually break up this force here into its components. We can break this up into two components, and the components would be, we would have, let me do this in a different color here, we would have a force that is parallel to this surface here. So one component of this force would break up into a force that is this way, which is parallel to this surface. So we will label that force that is parallel. So just using two lines that are parallel to each other to say that this is the parallel force. And then the other force would be perpendicular to this surface. Perpendicular, so I would draw it like this. Like so. I'm going to label it F, perpendicular. So this force of gravity, or the weight of the box, can be broken up into these two components, the force that is parallel to this incline and the force that is perpendicular to this incline here. Now, how can we go about figuring out then what is the amount of force this way and what is the amount of force this way? Well, if we think about this, we can actually know the angle. Let me get a different color here. We can know the angle that is right here. This angle between the force that is perpendicular and the force of gravity here, because this angle right here is going to be the same as this angle here. And think about this. Think about how this angle and this angle have to be the same, because let's imagine that I took this incline and I brought it down all the way down to 0 degrees. What's then going to happen to this angle right here as I start to bring this down to this horizontal 0 degrees? Well, this would begin to get smaller and smaller as well. It would change, right? This dotted line is always going to be perpendicular to this surface. And so if I bring this surface down to here, that means my perpendicular force is going to be the same. It'll be the exact same as this. It'll be the same thing, won't it? Right? So if I just real quick, if I draw that over here, if I bring the box flat, no longer on a hill, which that doesn't really look flat, but let's pretend it's flat, this perpendicular force is going to be the same as the force of gravity. They'll be the same thing, won't they? And then we can imagine that as I bring this upwards, right, this starts to get bigger and bigger, and it will get bigger at the same amount that this is right here as it changes. So you have to understand or make that connection that this angle here is going to be the same as whatever angle I've got here. So if that's the case, now I know that this right here, since these two angles have to be the same, so I'm going to say that this is 30 degrees right here. What I can do is I can use this method that we've been talking about, this vector analysis method, and I could take this vector here, my parallel vector, and I can move this down to right here and make that right triangle basically. So let's, and also what I could do is I could actually do the other thing. I could take this perpendicular vector, I can move this over this way and connect it here, and I would have an angle here that's 30 degrees. It would be the same thing, right? So let's get a little more room here and let's figure this out. So I've got let me get a different color here. So I've got the vector like this, which is the weight. And then I've got these other vectors here in red this way. Now obviously this is not drawn to scale, but that's all right, which is my perpendicular force. And what we're going to do is we're going to move this force down this way to make that right triangle. So like this. This is my parallel force. We know that this angle here is 30 degrees. And we now know that this right here is 90 degrees, right? And so now we can actually solve for what is my perpendicular force here and what is my parallel force here. We know, first of all, we have to figure out what is the amount of force here. So we said that this is the force of gravity, or the weight, which is mass times 9.8 meters per second. So I'll just round up to 10. So that's going to be 50 newtons, right? This is 50 newtons, mass 5 kilograms times 9.8. I'm just going to round 9.8 up to 10. So 5 times 10 gives me 50 newtons. So this is 50 newtons here. And so if I want to solve for this side over here, well, actually, let's do the parallel force first. So if I want to solve for the parallel force that is parallel to the incline, that's going to be equal to the weight of the object, this force here basically, times sine of 30 degrees, which means my perpendicular force here, would be equal to the weight again times the cosine of 30 degrees. And so if we actually plug those values in, so let's see, let me move this over a little bit. Our weight is 50 newtons times the sine of 30 degrees. 50 newtons times the cosine of 30 degrees. Let's plug those in to our calculator and see what we get. So, 30 times, so this would be 25 newtons. And 50 times the cosine of 30 would give us 43.3 newtons. And there's my components of the forces on an inclined plane. So again, the thing to remember is when we have something that's on a hill, we're taking this angle here, and whatever this angle works out to be is going to be equal to whatever this angle is here, and then I can break down my components based on whatever that is, using whatever the weight of this object is here.